Matrix arithmetic is going to be something totally new. It's a brand new section. So to start off, we're going to go ahead and define what in the world is a matrix, right? So it's not the movie. It's a mathematical thing that we do that it helps us out in many different occasions. But in this particular video, we're just going to go over matrix arithmetic, different operations we could do with matrix. So a matrix in mathematics is a collection of numbers that we arrange in rows and columns, and we enclose them with brackets. We denote them with a capital letter. So we give them a name always of a capital A, a capital B, and so on and so forth. Just so you guys know, matrix is only singular. When we talk about multiple, that's the word matrices. So matrix is one, matrices is plural. Now, when we're talking about a matrix, I could also ask you for the dimension of a matrix. I could call it a dimension, I could call it an order. The dimension of a matrix is kind of like if you were measuring it. You're going to give me two numbers. You're going to tell me m times n, where m is the number of rows and n is the number of columns. So if I ask you for the dimension of an order, you just count the rows, you count the columns, and that's actually the dimension of it. So we're going to do here just a couple examples just so you can get used to the idea of the dimension, finding the dimension of a matrix. So here they're asking us state the order of matrix A. Again, order is the same thing as dimension. All you have to do is just count how many rows does it have. Obviously, it only has one row. And then how many columns? Columns go up and down. So we have 1, 2, 3, 4. We have a total of 4 columns. So the order or the dimension of matrix A in this case would be a 1 by 4, right? That's the way you read it. So I'm just going to put a little by here. So again, it's like when you're measuring a room, right? It's a 10 by 8 or a 12 by 16 or a picture, like picture frames, right? So 4 by 6, it's the same thing. So matrix, this one's going to be a 1 by 4. Let's go ahead and try another one here. State the order of the matrix. Again, it's the same thing as a dimension. So we go ahead and count the rows. It's always the number of rows first. So we have a total of 2 rows and we have a total of 1, 2, 3 columns. So the order or the dimension of this matrix would be a 2 by 3. Okay, so pretty simple. And again, we are going to need this for future examples. So now that we know how to state the order, now we could go ahead and start doing some arithmetic. Again, arithmetic is kind of like multiplication, addition, subtraction, all that good stuff. We're going to go ahead and start with this thing called scalar multiplication. When I give you a matrix, I could give you a scalar or a number that I want you to multiply the matrix by. So here, scalar multiplication, it means that we can multiply a matrix, for example, matrix A, by a scalar. And a scalar is just going to be a number. The way you're going to see it is you're going to see the number in front of the name of the matrix. And that's all you're going to do. Now, in order to solve it or in order to compute it, all you have to do is multiply each element, every single little number inside the matrix by that scalar that I give you. That's going to be pretty simple. I know I just like over-explained it, but when we do an example, you'll see what I mean. So here we go. The instructions, this is all the instructions is going to say. Nowhere in there does it say multiply, but you should know when you have a number in front of the letter, it means multiplication. So I have my matrix A here, and I have a -3 in front of it. All this means is that I'm going to have to multiply every single number inside the matrix by -3. So this is going to be the work that I want to see when you solve this problem. So -3 times A means I'm going to have to multiply -3 times the -2, -3 times the 4, -3 times the 1, and -3 times the -4. Be very careful with your signs here, because if you do miss one sign, all of your matrix will be incorrect. So here, -3 times -2 gives me a +6. A -3 times a 4 gives me a -12. -3 times 1 gives me -3, and -3 times -4 gives me a +12. And here you go. This is your matrix of -3a. If you notice, all the numbers stay within or stay in the same order. You just multiply them by -3. When you do scalar multiplication, it does not affect the order or the dimension of the matrix. It used to be a 2 by 2, and the answer is still a 2 by 2. So order does not change. All right, let's go ahead and try one more here. So again, this one's still a 2 by 2. My answer is still going to be a 2 by 2. And here it says compute 2b. So that means I'm just going to multiply all of those numbers by 2. So 2 times 0 on the upper left corner, 2 times 3 on the upper right, 2 times -5 on the lower left, and 2 times 7 on the lower right. And all you have to do is just compute that. So 2 times 0 gives me 0, 2 times 3 gives me 6, 2 times negative 5 gives me negative 10, and 2 times 7 gives me 14. Okay, so I'm hoping you guys are enjoying these. These are really fun. Okay, so that's enough of scalar multiplication. Now we're going to go into matrix addition and subtraction. Now here is where the order or the dimension of a matrix is going to come in handy. You can only add or subtract matrices that have the same order. So you cannot add a 3 by 1 with a 1 by 2. They have to be exactly the same order. So if you want to add a matrix that has a dimension of 3 by 2, you have to add it to another one that also has a 3 by 2. Okay, so just be very conscientious of them. Okay, so to compute, if I'm asking you to add or subtract, it's super simple because all you have to do is just add or subtract the corresponding elements. So the first number that appears on the first matrix, you're going to add it or subtract it to the first number on the second matrix. It's going to be super simple. So let's go ahead and do a problem here. If you notice, the first thing I want you to do is ask yourself, are these two matrices the same order? So this one here is a 2 by 2. And this one here has 2 rows, 2 columns. So this one's also a 2 by 2. So since they're exactly the same order, then yes, I can add them. And to add them, you guys, it's going to be super easy. This number that's up here, you have to add it to the number that's up here. Okay? This number that's on the upper right has to be added to the number on the upper right. This number on the lower left has to be added to this number on the lower left. So if you mean corresponding, it just means on the exact same location. And then this number here on the lower right has to be added to this number here on the lower right. Okay, so again, I show my work. 1 plus 5 gives me the 6. The 4 plus 9 gives me a 13. 2 plus 12 gives me the 14. And then the 3 plus 7 gives me the 10. And that's it, you guys. That would be my final answer right there. Super simple. Again, addition and subtraction does not change the order or the dimension of the final answer. So since my original matrices were 2 by 2, my answer is also going to be a 2 by 2. All right, let's keep on practicing here. If you notice, now we have a subtraction problem. For subtraction, you have to be very careful with your signs. So again, first thing I do is check the order. This one right here is a 2 by 3. So this is a 2 by 3. And my second matrix here is a 2 by 1, 2, 3. It's also a 2 by 3. So since they both have the same order, then I could proceed and then subtract these two. But again, since this is a subtraction, you have to be very careful with the signs. So to start off, I'm going to go ahead and do the 3 minus a negative 2. So that's going to be my first answer up here. You see how we have two negatives, one because of the subtraction and one because the 2 was negative. So if you know, or if you remember, when you have a negative and negative, it becomes a positive. So this turns out to be 3 plus 2, which is how I got this little 5 here. And then you just keep on going. So we're going to have 1 minus a negative 4. So again, we have two negatives, which become a positive. That's how I got that positive 5. And then we just keep on going. So negative 1 minus a negative 3 also becomes positive. So negative 1 plus 3 gives me a 2. And then we move on to the second row. So we have 5 minus a negative 2. Negative, negative becomes positive. So 5 plus 2 gives me 7. And then I have a 2 minus a negative 1. So negative, negative becomes positive, giving me the 3. And the very last one is negative 4 minus a negative 3. So negative gives me positive. So negative 4 plus 3 gives me a negative 1. Okay, so this one was an example where all of these were negative, so that's why I had negative negatives in all of them. But of course, if any of these numbers would have been positive, then it would just be one subtraction. So it would have been like 1 minus that positive number. Okay, so again, the reason I put them all negative is just so you would practice that when you have two negatives, they become a positive. So just be very careful when you do that. But again, hopefully you agree with me that that was pretty simple. So that would be my final answer for this one. Okay, let's go ahead and try one more just so we could be very careful here. So this one again, they're asking us to compute. The problem has an addition, so obviously we're going to be adding. But before I do anything, I always have to check my order. So this one here is a 2 by 2. So this one's a 2 by 2. And this one here also has 2 rows. So it's a 2 by, and then 1, 2, 3. This one has 3 columns. So hopefully you should be like, Miss, I know you can't do that, right? Obviously we can. So the first one's a 2 by 2, the second one's a 2 by 3. Since they do not have the same order, then we stop here and we cannot add these because they don't have the same order. So I'm hoping you like this problem because again, you just stop there. You drop your pencil and be like, I can't do it. And that's it. So just be aware there's going to be some matrices that you cannot add or subtract because again, they have to meet the condition of having the same dimension or the same order. Okay, so I hope you had fun with those. Now we're going to move on to the last thing we're going to do, which is matrix multiplication. So up to now, you know how to find the dimension or the order of a matrix. You know how to subtract and add. You know how to do scalar multiplication. But now we're going to multiply one matrix times another matrix. Hold on to your horses because this one is where things are going to start getting a little bit weird. So just make sure you take good notes. So when we're going to do matrix multiplication, this is the condition, okay? And it's going to get kind of tricky, so just make sure that you have good notes, and then when we get to the examples, that you write down everything we're going to be covering. In order to multiply two matrices, pay attention to this part. The number of columns in the first matrix has to be the same as the number of rows on the second. That's the only condition. So two matrices can have different dimensions completely, but as long as the number of columns in the first is same as the number of rows in the second, you can multiply. Okay, I know that makes no sense, so let me give you an example. If I have two matrices, and let's say the first one has an order of 3 by 4, it has 3 rows and 4 columns, and the second matrix has an order of 4 by 2, meaning that it has 4 rows and 2 columns, you're always going to look at these two numbers, those two numbers, the ones in the middle. If those two numbers are the same, then you could keep on going with the problem. You're going to be able to multiply both of the matrices. So again, this is what I do. I put both of the orders side by side, and I check these two numbers. If these two numbers are the same, then we can multiply the matrix. Okay, now moving on to the second part. Once the problem satisfies this condition that both of those numbers are the same, now I have to find the order of the answer. So the order of the answer is going to be the other two numbers. So once you determine that, yes, I can multiply these two matrices, your answer will have the same number of rows as the first and the same number of columns as the second right here. So my answer after multiplying, my answer is going to be a 3 by 2. That's how I got this. Okay. So again, if you have no idea what I'm talking about, this is what you do. You check the order of the first one, you check the order of the second one. If these two numbers are the same, that means you can multiply them. And these two numbers on the outside is going to be the dimension of your answer. Okay, once you determine all of this, then you could actually move on and start multiplying. So to multiply matrices, this is what you're going to do. You're going to have to multiply each row on the first matrix times each column on the second matrix. I am not kidding you. It's going to get kind of confusing, but trust me, once you get the problems, you're going to be an expert on it. You're just going to do them super fast. So again, in order to multiply matrices, you're going to multiply each row on the first matrix times each column on the second matrix. All right, let's let the fun begin. So let's go ahead and do a couple examples here together. So here we go. Look at this tiny little innocent problem, and you're going to see how much fun it is. Again, before we do anything, we have to make sure that these two matrices are compatible and that we can multiply them. So we're going to have to write the order of this one. This one has 1 row and it has 2 columns. So it's a 1 by 2. This second matrix has 2 rows. So this one's a 2 by, and it has 1 column. So it's a 2 by 1. And I totally forgot I had it right there. So my first matrix is a 1 by 2. My second matrix is a 2 by 1. In order to see if I can multiply these matrices, remember, we always check these two numbers. Since those are the same, that means, yes, I can multiply these two matrices. Now that I determined that, I have to check these other two numbers. That's going to be the dimension of my answer. So my answer is going to be simply a 1 by 1. So I'm just going to do a super tiny square. It's just going to be a 1 row times a 1 column. So believe it or not, my answer to this problem is just going to be one number. That's it. So hold on. I'm going to go ahead and explain how to multiply matrices. To multiply matrices, to find this answer, you're going to have to multiply row 1 in the first matrix times column 1 in the second matrix. So you're going to multiply this whole row times this whole column. How in the world do you do that? Super easy. You're going to multiply the first number in this row, which is the 2, times the first number in this column, which is the -1. So you're going to do 2 times -1. And then you're going to do the second number times the second number. So 3 times 5. So this is what you're going to do. Okay, and again, I'm going to go over it because I know this is very confusing. You're going to multiply the first row, which is actually the only row, times the first column, which in this case is the only column. You multiply the first number times the first, so 2 times -1, and then the second number times the second number, so 3 times 5 right there. Okay, and then you have my permission to put that straight in the calculator. 2 times -1, you could put the whole thing in the calculator, but I'm just going to do it in my head. 2 times -1 is -2. Oh my goodness, -2, there you go. Plus 3 times 5 is 15. And then -2 plus 15 is 13. And voila, there you go. That's my answer to the multiplication of those two matrices. I know it makes no sense, but that's how you multiply matrices. So we multiplied a 1 by 2 times a 2 by 1, and we ended up getting a 1 by 1, which is just a single number. But it's still a matrix, so you still have to put these little symbols on the side. Okay, so I'm hoping that kind of made sense, because now we're going to jump into a little more intense problem. So don't freak out, but let's go ahead and try this one. Here we go. Before you do anything, let's check if they're compatible, because maybe they're not and we don't have to do anything. So let's go ahead and try this one. This one has 2 rows, 2 columns. So this one's a 2 by 2. And this one has 2 rows and 2 columns. So this one's actually also a 2 by 2. Now, again, I don't care if they're exactly the same. I only care about these two numbers. So I have it right there. We have a 2 by 2 and a 2 by 2. So since these two numbers in the middle are the same, then yes, I'm going to be able to multiply these two. And now these two numbers give me the dimension of my answer. So my answer is going to be a 2 by 2. All right. So my answer is going to be a 2 by 2, meaning that I'm going to have 2 rows, and 2 columns. So I'm going to have 4 elements inside. So in order to multiply these two matrices, I'm going to have to do a total of 4 different computations, because I have to find the 4 elements in my final answer. Now, don't panic. I'm going to try my best to color code this just to guide you on how to do it. So again, we're going to have 4 answers. Let's go ahead and start by figuring this one out. So to figure this one out, this one is in row 1. So I'm going to come over here and multiply row 1. And it's in column 1. So I'm going to go ahead and multiply column 1. So in the first matrix, you're always going to use the rows. And in the second matrix, you're always going to use the columns. So I'm going to come over here and I'm going to multiply row 1 times column 1. And that's how I'm going to find this little number here. And just like we did on the other one, you always multiply the first two numbers. So -2 times 5. And then the second number is 3 times 0. So that's how I get that. Okay, so hopefully you were able to catch that. Again, since we're only doing the first one, this is row 1, column 1. So row 1, column 1. And then you just compute this. So -2 times 5 is -10. 3 times 0 is 0. So -10 plus 0, is going to give you -10. So my answer for this one is going to be -10. Okay, if that made no sense, don't worry. Let's go ahead and try the next one. Okay, so now let's go ahead and do this little box right here. To do this box, we're going to do, this is row 2. So now I'm going to go ahead and multiply row 2, which is this right here. And it's still column 1. So now I'm still going to multiply it times these. Okay, that's going to give me the answer to this one, again, because it's row 2. So row 2 in column 1. So 0 times 5. And then the second number is 1 times 0, which is this. Okay, so 0 times 5 is 0. 1 times 0 is 0. So 0 plus 0 is obviously 0. So that's, I'm going to get a 0 right there. Okay. I'm hoping you're having fun here, because I am. All right, let's go ahead and continue here. We obviously now have to move on to this one. So this one, again, in order to know what you're going to multiply, you just have to ask yourself, what row and what column am I in? So this blue box, it's in row 1. So that means I'm going to multiply row 1, but times column 2. So this is column 2. So now I'm going to come and use column 2. Okay, so row 1 times column 2. Now, what I'm going to do is, again, just multiply the first number. So negative 2 times negative 2. If you notice, that's how I got that. And then 3 times 5. So 3 times 5. And again, then you just add them together. So negative 2 times negative 2 is positive 4. 3 times 5 is 15. So 4 plus 15 gives me 19. Okay, look at that. We're almost done. We're just one square away from finishing. Okay, what color should we use now? Let's use, hopefully you can see the yellow. All right, so now we have to find this number right here. So this number, again, ask yourself, where are we? This is row 2. So we're now in row 2. So we're going to use this one. And I'm sorry about my mess, but I'm trying to color code it. And then we're in column 2, sorry. So row 2, column 2. So now I'm going to use column 2, which is going to be these two numbers. Okay. And then again, you just multiply the first, the second, the second. So 0 times negative 2. It's going to be the first computation. And then 1 times 5. And then you just add them. So 0 times negative 2 gives me 0. 1 times 5 is 5. And then 0 plus 5 gives me just a 5. And then look at that. Wasn't that fun? That's it. So that would be our final answer. So I'm going to go ahead and erase all my mess. Let me just go ahead and make sure my answers, yeah, they do match. And that's how you would do it. Okay, you guys, so I know it's a lot of computation, but just so you know, that's the way you multiply matrices. For any written assignment that I give you guys, I do have to see this right here. Okay, you cannot just jump from here to here with no work. So whenever it says multiplication, you do have to show me the setup. Of course, from here, you could just put that in your calculator and get the answers from there, but I have to see your setup. Okay, so if you have questions about that one, let me know. But let's go ahead and just do one last one for this video. So again, compute, oh my goodness, this is such a bigger problem. But again, we first have to check the dimensions to see if they're compatible. So you guys give me a minute. I lost my cursor. My goodness, there we go. Okay, so on this problem, we have to find the order of this one. So this one's a 3 by, it has 3 columns. So it's going to be a 3 by 3. And then this one has 1 row times 1, 2, 3 columns. There you go. Awesome. So we have our orders there. Of course, in order to see if I could multiply these, I have to check the numbers in the middle. And look at this. Oh my goodness, we just saved ourselves a lot of work because these two are not the same. That means that these two matrices cannot be multiplied. So again, I meant to make it look scary. So hopefully I scared you. But if you notice, since the two numbers in the middle are not the same, then you just stop, drop your pencil, and be like, these two cannot be multiplied. If you need help, I can also show you how to multiply these in the calculator to double check your work. And if you were, just so you know, if you were to put this in your calculator, your calculator would tell you a little error because you cannot multiply. So again, hopefully you agree with me. It's pretty simple. Matrices are pretty fun. But if for some reason you do need a little bit more help, just reach out to me and we can, of course, do more examples together.